Hello everyone, this is chapter 20, the last chapter of business math. We're going to be talking about annuities, and on each section you'll see a little bit different things that we do with our financial calculator. So here's some terminology. An annuity is a series of payments, and term of the annuity is the time from the beginning of the first payment period to the end of the last payment period. Future value, the future dollar amount of a series of payments plus interest. Present value, the amount of money needed to invest today in order to receive a stream of payments for a given number of years in the future. So you could be paying into it, you could be receiving from it. So here is, we've talked about a chart similar to this, or a graph similar to this. On this one, this would be where you're depositing $1 at the end of each period at 8% interest. So on this one, if you were using the financial calculator for this, then you would have a period of 3. Your interest rate would be 8. It would be an annual rate, and then in this case you would be then for payment, you would be putting in $1 each payment, and then at the end of this your future value would end up at $3.25 if you round it. So that's what this is a picture of, is here's what would happen over this period of time for 3 years, and you would end up with this much money having invested $1 each year, right? So you'd have $1, you'd add another one, you get a little more interest, and so on. Okay, so we talk about these a little bit, and then for the most part we're just looking at the kind of annuities where the payment's made at the end of the period or the beginning of the period, and so we just have to make sure we know which one it is. Contingent annuities have no fixed number of payments but depend on an uncertain event like a life insurance payment or something. Annuities certain have a specified stated number of payments like mortgage payments on a home. Ordinary annuities, regular payments made at the end of the period, and it could be months, quarters, years, and so on. Annuity due is regular deposits made at the beginning of the period, such as rent or life insurance premiums. Now, it does make a difference on what happens if it starts at the beginning versus the end, and I will be showing you how to set your calculator for whichever one we happen to be doing. Okay, beginning or end is what I'm trying to say. Okay, so on this one, it's calculating future value of ordinary annuities by financial calculator. So remember, ordinary are regular deposits made at the end of the period. Okay, so on this one, it says the payments at the end of the period. The payment amount is $4,000. It's semi-annual, 9 years, the interest rate is 7. So basically we're just going to fill out our chart, and then using our financial calculator we will determine, in this case we're going to find the future value of this. So for 9 years, semi-annual is going to be 9 times 2, so 18 periods. The interest rate is 7%. We're going to divide that by 2. So it will be 3.5%. Remember, we just put that in as 3.5. Your calculator knows that that is in percent form. There is no present value, but we are making a payment of $4,000. Whoops, I had an extra 0 on there. Let's not do that. Okay, and then we simply will compute future value, right? And so compute future value, and you find that you would end up with $97,998.77. Now that's a pretty good payment there. So basically in a year's time you're putting in $4,000 for each, or $8,000, right? $4,000 2 times each year. Now we're going to do that same problem, but this time we're going to put our calculator on begin mode, and then you'll have to put your calculator back on end mode for other problems. So you kind of go back and forth. We fill out the chart basically the same, but now let's think about what happens here. Now remember on the previous chart we had 18 periods. Our interest rate was 3.5%. We did not have a present value, and we were making a payment of $4,000, but this time it's going to be at the beginning. So now think about this. At the very beginning of this thing, you put in $4,000, so it starts to accumulate some interest because it's already in the account for that first month. And so at the end of this, it does make a difference. We are going to still compute future value. Now let's talk about your calculators. You're going to press second begin, and the begin is above payment. So right above the payment, you push second begin, and then you push second set, which is above the enter key. So notice this one's right above payment. This one's right above enter on your calculator. When you have it set correctly into begin mode, it will say BGN up at the top of your screen on your calculator. So then you know you're in begin mode. It will make a difference on how you what you compute. So you have to be careful that you have it set on begin or end, which will be specified in the question that you're working on. Okay, so when we compute this time, it's 101,000 if I can only say this, $428.72. Now for begin mode, we ended up with a little bit bigger number than we did with end. And the reason for that, remember, is because we put that money in at the beginning. So on this one, we were close to 98,000. On this one, we're at 101,000. So it does make a difference because it allowed it to start accumulating the interest sooner. Okay. Here's the next one. We're back to the end. Okay. So to get it out of begin mode, you press second begin, second set, and now we'll be in end mode. Now when it's in end mode, it doesn't say anything on your screen, so you just basically know it's in end mode because it doesn't say begin or BGN on your calculator. So remember, we just go back second begin, second, I was thinking set, second set, to be back in end mode. Okay, so just be on the lookout for that, and it'll be clear on your calculator when it's in begin mode because you see it right there on your screen. Okay, now we're going to take the same problem, and we're going to do a little bit different with it. On this one, it's still going to be 9 years, but now we're on quarterly. So 9 times 4, it will be 36 periods. Our interest rate will be divided by 4. So it is 1.75%. Present value still at 0. Our payment is $4,000. And then we're going to compute future value. Okay. So the payment is the same, but it just is not really, because instead of just being twice a year, it's 4 times a year. So we're actually putting $4,000 in every 3 months versus every 6 months. This makes a huge amount of difference. When you compute this time, you see that you have $198,264.52. So definitely does make some difference because, especially with such a large payment, it's going to make a significant difference over twice a year and 4 times per year. Now we're going to go back and do the same problem again, and we're going to use begin mode. So once again, right? Second begin, second set, and you'll see BGN on your calculator screen. All the info is the same as the last problem on number 3 that we just did. And we're still computing future value. And it will be a little bit more once again than it was on the last question, because we start computing that interest quicker. Actually, thinking on the semi-annual, when we put it in at the beginning of the period, it was at the beginning of the 6 months, so it was able to accumulate during the 6-month period. And then this one's a 3-month period before that, you know, in the beginning, begin versus end. I think earlier I was saying a month, but it was not really, it was more time than that. Okay, so here's what we end up with. And once again, we are at about $3,000 more than we were for the end mode. Let's see, time. Okay, I think we can do this problem before we run out of time here. Okay, on this one it says you decide to reduce the amount you spend eating out by $175 a month and invest the total saved at the end of each year in your retirement account. How much will the account be worth at 6% in 15 years? So remember to get back out of begin mode into end mode. And this is $175 12 months of the year, but we're just going to invest it at the end of the year. So this is going to be an annual investment per year. Okay. And so if we're using annual interest, we make this payment at the end of the year, $2,100. It's going to be 15 times because it's for 15 years. And then 6% interest. It's annual, so we're only dividing by 1. Present value is 0. And once again, we are computing future value. What's this going to be worth at the end of the 15 years? So it is $48,879.54. And I believe we'll stop on this one and pick up the rest of this lesson on a second video. Bye, everyone.